Hello class. Okay, today we shall be continuing on our chapter of periodic table. So please take out your notes 14a, introduction to the periodic table. We actually have done this part and also on the 14b group properties for group 1 metals. Alright, today we shall be carrying on with the next group, okay, which is group 7 halogens. Alright, so let's get started. Okay, group 7 elements, as the title has said, okay, they are called halogens. Right, that's their special name. Okay, much like group 1 metals are called alkali metals, group 7 elements are called halogens. Alright, so the general properties of halogens are they are non-metals that exist as diatomic molecules. Okay, and what do I mean by diatomic molecules? Okay, please write this down. Diatomic means, okay, two atoms combined. Okay, yeah, so that's why naturally fluorine, chlorine, bromine and iodine, they will exist as diatomic molecules. They will not be alone. Okay, they will be like this. There will be two atoms combined. So F2, Cl2, Br2 and I2. Yeah, so that is a special property of the group 7 halogens. Also, since they are non-metals, okay, they have low melting and boiling points, okay, because they form covalent molecules and thus have weak intermolecular forces of attraction, okay, between the molecules. So a small amount of energy is needed, okay, to overcome the forces of attraction. Okay, that's why they have low melting and boiling points. And a special property of group 7 elements are, okay, they are colored. Okay, many elements are colorless. Okay, you can think about it. Okay, the oxygen and nitrogen in the air are colorless. Okay, but for group 7 elements, they are colored. Okay, so what are the group 7 elements? Okay, we have fluorine, chlorine, bromine, iodine and astatine. Alright, much like the group 1 elements, okay, we are going to look at the trends in the properties of the halogens. Okay, so trends being, okay, the pattern. Okay, alright, so these trends you need to memorize, okay, and it's not that difficult. Okay, we will do a summary at the end of the lesson later. Okay, let's look. Okay, so we have the 4 halogens here, excluding astatine. Alright, so we have their melting points, we have their boiling points, and followed by how they appear in room temperature. Okay, so fluorine appears as a pale yellow gas, chlorine appears as a greenish yellow gas, bromine appears as a reddish brown liquid, and iodine appears as a purplish black solid. Okay, all of these appearances are in room temperature. Okay, let's look at the pattern. Okay, or let's look at the trends. So going down the group, as we go down the group, what do you see? The melting points and boiling points of the halogens, do they increase or decrease? Right, that's right. Okay, the melting point and boiling points increases. Okay, this is the opposite of the group 1 alkali metals, where the melting points decreases down the group. Okay, next, let's look at densities. Okay, densities refer to how close the molecules are in the element, okay, or to be more precise, okay, how many atoms are there in one unit volume. Okay, so it's related to how close they are. So as you can see, okay, fluorine, chlorine are gases, bromine is a liquid, then iodine is a solid. Okay, referring to these states, which one you think there are more molecules closer together, solids or gases? Okay, all right, if you said solid, good. All right, so solids have molecules closer together, followed by liquids, and gases, the molecules are far apart. Okay, so therefore solids, okay, have higher density than liquid, which is higher density than gases. Okay, when we talk about densities. Okay, why? Because solids have more particles, okay, closer together in the same volume as compared to gases and of course liquids. Alright, so as you go down the group, the densities of halogens increases. Okay, alright, from the particles being far apart, okay, they get closer, liquid, and finally when it's iodine, they are solid, very close together. And what do you see? Okay, the colors also you need to memorize. Okay, we start from pale yellow. Okay, then we have greenish yellow. Then we have reddish brown. Okay, followed by purplish black. Okay. All right, what do you see about the colors? Okay. All right, the colors of the halogens, a simple way to say is they darkens. Okay, down the group. Okay, from pale yellow become greenish yellow, become reddish brown, and then finally purplish black. So the color becomes darker. Okay, so applying these following trends, okay, can you make a prediction of the melting point and the appearance of astatine? Alright, as you can see, okay, the melting points of the halogens increases down the group. Okay, astatine is below iodine. Okay, and the appearance of astatine. Okay, the color will darken and also the density will increase. So what do you think? Alright, so for this kind of questions, okay, if you can make a correct prediction, okay, it's usually a range. Alright, you'll get the answer. Okay, so for this question, okay, if you give, okay, any temperature above 114 degrees Celsius, okay, you'll be right because that is the trends in going down the group for group 7. So the melting point of astatine, okay, you can say it's more than 114 degrees Celsius. Okay, next. Okay, looking at the appearance, the pattern. Okay, first things first, what do you think the state of astatine will be? Gas, liquid, or solid? Alright, and it is solid. Alright, because the density increases and also the melting point is higher than iodine. If iodine is already a solid, okay, astatine would definitely be a solid. Alright, and the color. Okay, first we have pale yellow, greenish yellow, reddish brown, purplish black. So the color of the halogen darkens. What is darker than purplish black? Yeah, and the answer is really, okay, it is a black solid. Alright, so this is how you can make predictions, okay, using the periodic table. Okay, and finding out, okay, about the next element, although it's not given in the table. Okay, by the way, astatine is one of the rarest elements in the world. Okay, there's only a few grams, okay, in the entire earth. Okay, it's actually quite hard to find. Yeah, so using this we can actually find out, okay, what it looks like, okay, looking at the trends. Okay, if you want to know, the exact melting point of astatine is 302 degrees Celsius. Okay, you don't need to memorize lah, but I'm just telling you. Alright, moving on. So we shall now talk about the trend in the chemical properties of halogens. Okay, halogens are reactive non-metals. Okay, they are kind of like the opposite of the group 1 elements, where they are reactive metals. Right, and since they are in group 7, they have 7 valence electrons, and therefore will require only 1 electron in order to achieve stable noble gas electronic configuration. Alright, so they require only 1 electron, okay, to achieve stable noble gas electronic configuration. Alright, since they only just need to gain 1 electron, alright, they are very reactive. Okay, so of course it's quite easy for them to just gain that 1 electron to react. And when halogens react, okay, with most metals, they will form halides. So example, sodium and chlorine, they will form sodium chloride. Right, so when I talk about halides, okay, it's just a way of calling the halogen inside the compound. So example, we have the chlorine halogen here and the chloride halide. Okay, so we have the halide, chloride. Okay, the element itself is chlorine. Okay, and after it reacted, it becomes a halide, chloride. Okay, and you need to memorize the reactivity of halogens down the group decreases. Okay, this is the opposite of the alkali metals, where as you go down the group, they increase. Okay, group 7 elements, as you go down the group, the reactivity decreases. Alright, so okay, because of the reactivity, we can talk about a special reaction that involves the halogens. Okay, we call it displacement reaction. Okay, so what is a displacement reaction? Okay, a displacement reaction is a reaction in which one element takes the place of another element in a compound. Alright, you can imagine it like a substitution in a football match. Okay, where one element comes in and another element comes out. Okay, so that is displacement. Right, before that, okay, we have the 5 halogens here. Right, so the reactivity of the halogen decreases down the group. So very importantly, can you write here? Okay, fluorine is the most reactive. Okay, then the reactivity decreases down the group until we reach S13, which is the least reactive halogen. Right, so what is displacement reaction? Okay, if we were in the class, okay, I would have done a role play for you all. Okay, but instead, okay, I've made some drawings to explain it better. Okay, so, alright, let's say, alright, we have sodium chloride in a solution. Okay, this is the compound. Okay, they have reacted. Okay, yeah, so the sodium and the chlorine are holding hands. They are a compound and they are in solution. Okay, in solution means they are dissolved in water. Okay, and fluorine is more reactive than chlorine. Okay, very important. It's more reactive. Okay, so fluorine is more reactive than chlorine. So what will happen is fluorine can come in and kick out chlorine. Okay, and take the place of chlorine. So in this case, chlorine is displaced. Okay, yeah, so the more reactive fluorine can come in, okay, and displace chlorine. Okay, yeah, so this is what I mean by displacement reaction. So initially you have sodium chloride, okay, but you end up with sodium fluoride. Okay, the fluorine kicks out chlorine. Okay, conversely, okay, if we have sodium chloride, okay, once again they are in a compound in solution, okay, but bromine tries to displace chlorine. Okay, but bromine is less reactive. Okay, all right, since going back to here, bromine is less reactive than chlorine. So since bromine is less reactive than chlorine, okay, it cannot displace chlorine. Okay, chlorine is too strong. So therefore, okay, displacement does not occur. All right. So if there's a less reactive halogen trying to kick out a more reactive halogen, it will not happen. Okay, displacement will not occur. So same, if I use iodine to try to kick out chlorine, it also will not happen. Alright, so the only one that can kick out chlorine is fluorine, because fluorine is more reactive than chlorine. Okay, and so example, if I have sodium bromide, okay, sodium bromide, okay, chlorine can kick out bromine, fluorine can kick out bromine, but iodine cannot kick out bromine, astatine cannot kick out bromine. Alright, so that's what I mean by displacement reaction. Okay, yeah, so this is a visual representation. I show again. Okay, the more reactive fluorine can kick out the less reactive chlorine. Okay, but the less reactive bromine cannot kick out the more reactive chlorine from its compound. Okay, right, that is the a picture representation of the displacement reaction. But if you really want to see how it looks like in real life, okay, when you have solutions, okay, you can scan the QR code, okay, in your notes, okay, and it will take you to a YouTube video showing it. All right, so going back, okay, very important concept. A more reactive halogen will displace the less reactive halogen from its halide solution. All right, okay, if you look at the video, okay, later you'll see that many of the colors don't seem to match what we talked about just now. Okay, all right, we talked about, okay, chlorine being greenish yellow, okay, bromine being reddish brown, and iodine being purplish black. Okay, but when you look at the video, okay, it will be different because they are dissolved in solution, so the colors are slightly different lah. All right, so in the example below, the halide solutions, okay, all these solutions, okay, right, going back, okay, right, the solutions, the compounds are colorless. Okay, and when there's a displacement, okay, usually you can get a change in color. All right, so let's see. All right, let's see. I have chlorine, okay, and sodium bromide. Okay, chlorine is the one trying to kick out, okay, bromine from the sodium bromide. Okay, will that happen? Okay, if you look back, okay, chlorine is more reactive than bromine. Okay, so very important. Can you write there? Chlorine more reactive. Okay, comparing to bromine, bromide. So since it's more reactive, it will come in and kick out bromine to become sodium chloride. And what comes out is bromine. Okay, so chlorine kick out the bromide, okay, becomes sodium chloride, and the bromide comes out as bromine. So what you will see is from a colorless solution, you add, and then it becomes reddish brown because bromine comes out. All right, so now once again, chlorine is also more reactive, okay, than iodine. Okay, iodine is less reactive, so chlorine can kick out iodine, so chlorine comes in, kick out, becomes sodium chloride, and iodine comes out. Okay, this time instead of getting a reddish brown liquid, okay, you get a dark brown liquid. Okay, all right, you don't get the purplish black solid, okay, because they are in solution. Okay, iodine, you see it as a dark brown liquid. All right, and same thing, okay, for bromine is more reactive. Okay, then iodide. Okay, bromine can kick out, okay, because bromine is more reactive than iodine. So bromine can kick out iodine, you get sodium bromide and iodine come out. Okay, but this one is a bit harder to see. From a reddish brown solution, you get a dark brown solution. So the solution becomes darker. Right, okay, so knowing this, okay, all right, you might want to look at the video and try to understand better. All right, okay, but if you still don't quite understand, okay, just remember, okay, the more reactive halogen can kick out the less reactive halogen from its solution. All right, and very importantly, okay, if I have a less reactive halogen, okay, all right, a displacement reaction will not occur. So example, bromine, okay, comparing to chlorine in sodium chloride, okay, there will be no reaction because bromine is less reactive. Okay, yes, bromine is less reactive than chlorine, so it cannot kick out. Conversely, if I try to add iodine to sodium bromide, okay, there will not be a reaction because why? Iodine is less reactive than bromine. Okay, and that is displacement reaction. Right, so finally, we'll do a summary of what was covered. Okay, so the summary for the trends in the properties of group 7 halogens. Okay, please take note. Okay, these trends you need to memorize. Okay, so down the group, the melting point and boiling points increases. Okay, the density increases. Okay, reactivity decreases. Okay, and the color darkens. Okay, all right, so please memorize these trends. All right, so let's do a general summary of all the 3 groups that we've covered, okay, for this topic. Okay, group 0, okay, do you remember what's the special name for them? All right, yes, that's right, they are noble gases. All right, and their general property are they are monoatomic. Okay, that means they exist as single atoms. All right, and they are unreactive, okay, because they have completely filled valence electrons. Okay, for group 1, the special name is alkali metals because they react with water to form alkalis and hydrogen. All right, general properties, relatively to other metals, they have low melting point and boiling points. And relatively to other metals, they also have low density. Okay, and they are highly reactive metals. Okay, for group 7, the special name is halogens. The general properties are they are diatomic, okay, not monoatomic, they are diatomic. Okay, exist as 2 atoms joined together. Okay, they have low melting point and boiling points, they are colored, and they are reactive nonmetals. Okay, comparing the trends. Okay, for alkali metals, okay, the melting point and boiling points decreases down the group, density increases, reactivity increases. Okay, for group 7, on the other hand, okay, the melting point and boiling point increases, the density increases, reactivity decreases, and a special property for them, their color darkens. So as you can see, okay, the group 1 and group 7, okay, the trends are slightly opposite, okay, when it comes to the reactivity and the melting point boiling points. Okay, but for both of them, their density increases. Okay. Alright, so that's it for the periodic table chapter. Okay, so you need to know the various properties for these groups and also their trends, okay, and their reactions. Okay, for group 1, the reactions with water to get the alkali and hydrogen. And for group 7, you need to know about the displacement reactions. Alright, take care.